So welcome to the channel. Myself is Prabhu VS, Assistant Professor from RMD Engineering College, and in this video we are going to see about Bluetooth. As we all know, Bluetooth is a common standard used by the mobile phone for communication. That is a short distance communication, right? So Bluetooth operates in 2.4 gigahertz ISM band. So ISM refers to industry, scientific, and medical frequencies. Okay, so and the Bluetooth operates on 79 channels in the 2.4 gigahertz band, and it has a spacing of 1 megahertz. So each channel is spaced around 1 megahertz, and each device performs hopping with 1600 hops per second in a pseudo random fashion. So this follows the FHSS, that is frequency hopping spread spectrum. So it applies FHSS for interference mitigation. So FHSS is a standard technique, as we all know. So if you see the Bluetooth architecture, the main thing is the Piconet over here. So the Piconet is nothing but the combination of this master, slave, parked, and standby. So four components were involved in this simple Bluetooth Piconet. So there will be one master, and there will be a lot of slaves. Maximum of 7 can be accommodated, and we have so many parked and standby. So parked means they are not been right now connected, and they are ready to be connected, and standby the one which was standing outside, and it can also be connected later. So Piconet is a collection of devices which are synchronized to the some hopping sequence. So each Piconet, as already I told, has the master and up to 7 simultaneous slaves. So totally 8 will be available, will be connected, and the parked and the standby will be out of that. So the reason for this is each Piconet, each components in the Piconet will be connected in a 3-bit address used in the Bluetooth. So starting from 000 and 111. So totally we have some 8 devices can be connected, one master and 7 slaves. The first step involves in a master sending its clock and device ID. So these two things will be sent. Say for example, if you take this as our Piconet, we have so many slave masters and one master and so many slaves, and thereby we have another part. So if a new network have to be, or if a new device have to be get connected, it will be sending its clock and device ID. The hopping pattern is determined by the unique device ID, a 48-bit worldwide unique identifier. So the device ID is an 48-bit worldwide unique identifier. The phase in the hopping pattern is determined by the master's clock. So all users within one Piconet have a same hopping sequence and share the same 1 megahertz channel. So as we all know, this the components or the devices connected in one Piconet have the same 1 megahertz channel. As more users join the Piconet, the throughput per user drops quickly. So as the traffic increases, the throughput also decreases. This lead to the idea of forming groups of Piconet called the scatternet. So this is a very important concept in the Bluetooth. So nowadays even up to 5.2 version of the Bluetooth is available. They follow this scatternet. In the example, the scatternet consists of 2 Piconets. So for example, one Piconet contains one master and 7 slaves, and another Piconet contains one master and 7 slaves, and both will be connected here. So in which one device participate in 2 different Piconets. So that one device itself will be connected in the 2 Piconets. Both Piconets use different hopping sequence, always determined by the master of the Piconet. So if we can able to see over here, so here is the one Piconet, and this is the another Piconet, and some slaves are being. So here you can see one slave is connected to both the Piconets. So this is what we call the concept as scatter net, and each with a capacity of less than 1 megahertz. So this is a simple illustration about the Bluetooth. Thank you.